Hi everyone, welcome to the Student Brand. Today we are going to discuss about light reflection and refraction. Light reflection and refraction. So in the previous live class we discussed about until in the previous live class until ray rules we discussed. Until ray rules we discussed. We are going to discuss about image formations. Now we are going to discuss about image formations. Image formations by concave mirror and convex mirror. Concave mirror and convex mirror. Now see, image formation by concave mirror and convex mirror. So I am considering the concave mirror. So this is the concave mirror. Concave mirror. So in concave mirror, so if the object is placed at infinity, in concave mirror, if the object is placed at infinity, image will form at focus. If object is placed at infinity, image will form at focus. So I am considering this one. First, anywhere we can take a pole, focus, center of curvature. So this is the pole, focus, and center of curvature. Pole, focus, center of curvature. So one light I am taking. So object is at infinity. First point is object is at infinity. So one light I am taking like this. So one light I am taking like this. So after reflection, light ray will pass through the focus. Light ray will pass through the focus, and another light ray I am taking. Light ray will pass through the focus. So here you can see. So another light ray I am taking like this. So after reflection meet at focus like this. So image will form at focus. Image will form at focus. So what is the nature of the image? Real and inverted. So what is the nature of the image? Real, inverted, and highly diminished. So what type of image will form? The real, inverted, and highly diminished image will form. Real, inverted, and highly diminished. Real, inverted, and highly diminished. So if you are taking object and infinite, object is at infinity, image will form at focus. So nature of the image is real, inverted, and size of the image is highly diminished. I mean, coming to the next one, coming to the next image formation. So if you are taking the concave mirror, I'm considering the concave mirror. I'm taking the concave mirror. So this is the pole, focus. So pole, focus, center of curvature, pole, focus, center of curvature. So object is placed beyond center of curvature like this. Object is placed beyond center of curvature. One light I am taking like this. One light I am taking like this. It passes through the focus. It passes through the focus. Another light ray passes through center of curvature. Another light ray passes through center of curvature. It reflects back. As we know, the light is passing along the normal line. If you are taking light, if the light is passing along the normal, what happens? So it will reflect back into the same medium. It reflects back into the same medium. Here also same thing. If the light ray passes through center of curvature, it reflects back into the same path. So it reflects back into the same path. So image will form here. So the image will form between C and F. So the image will form between C and F. Here the image will form. So object is beyond C. Object is beyond C. Image will form between C and F. Image will form. Mr. Harris. Hey, hi. What is your name? So image will form between C and F. Image will form between C and F. So between C and F. Nature of the image is real, inverted, and size of the image is diminished. So here you can observe, if the object is placed beyond center of curvature, image will form between C and F. So here they will ask one question: what type of light rays used to use what type of light rays? Okay, ray rules. What are the ray rules you used to get the image formation? So they will ask about the ray rules. So you must understand. You must learn about ray rules also. So object is placed beyond center of curvature. Image will form between C and F. Object is placed beyond center of curvature. Image will form between C and F. What is the nature of the image? So real, inverted. What is the nature of the image? Is real, inverted, and size of the image is diminished. Coming to the next one. So I'm taking one light ray here. So this is the pole, focus, and central curvature. Pole, focus, central curvature. Object is placed at C. Object is placed at C. So here, and image also will form here. One light I'm taking like this. It passes here. It passes through focus. Another light I'm taking, so it meet at pole like this. I'm considering here. So here it will reflect like this. I'm considering object at C. Object at C, image also will form at C. Object at C, image also form. Image also will form at C. Nature of the image is real inverted and size of the image is same size. Size of the image is same size. Size of the image is same size. And coming to the, so here is third one. And coming to the fourth one, fourth image formations. Fourth image formation. So fourth one, you can see fourth one. So if the object is placed, so I'm taking one more image formation. So I'm considering like this. Okay. So if the object is placed, so here focus, central curvature. So I'm considering the object here. Object is placed between C and F. Object is placed between C and F. One light I'm taking like this. One light I'm taking like this. So it passes through focus. It passes through focus. Another light ray. So I'm taking at the pole. I'm taking at the pole. So the light rays will meet here. So here I'm considering like this. This I'm considering here. Okay. So here the light rays will meet here. Object is placed between C and F. Object is placed between C and F. Image will form. Image will form between beyond C. Image will form beyond C. Beyond C. Beyond C. Nature of the images. 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 Real inverted. Real inverted and enlarged. Real inverted and enlarged. So very very important. These are the four. And the next one, fifth one. Coming to the fifth one, so I'm taking the light rays. So here I'm considering like this. So object is placed. So pole, focus, central curvature, pole, focus, and central curvature. One object is placed at focus. Object is placed at focus. One light ray passes through like this. Another light ray I'm passing. So those light rays will meet at infinity. Object is at F. Image will form at infinity. Nature of the image is nature of the image real inverted and highly enlarged. Real inverted and highly enlarged. Real inverted and highly enlarged. So you can observe. So if the object is placed at F, image will form at infinity. Image will form at infinity. So nature of the image is real inverted and size of the image is highly enlarged. And coming to the sixth one is very very important. Last case. Okay, so in concave mirror, so they will ask for 3 marks question definitely. So applications are also very, very important. Applications point of view, this question. So pole, focus, and central curvature. So I'm taking the concave mirror. So this is a concave mirror. So what is this mirror? Concave mirror. Object is placed between F and P. 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 How many light rays are required to form the image of the object? How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. I am taking, so one light ray through focus, another light ray through central curvature. So if you are extending those light rays will meet behind the mirror. Behind the mirror means back side of the mirror. So here, so in this case, so here the image will form here. So what type of image will form? Virtual erect and enlarge, virtual erect and enlarge, virtual erect and enlarge. So image will form here behind the mirror. So image will form behind the mirror. Image will form behind the mirror. Image will form behind the mirror. So what is the nature of the image? Virtual erect and enlarge. Virtual erect and enlarge. Why we are taking virtual erect and enlarge? Because so we are extending the reflector light rays. We are extending the reflector light rays. Reflector light rays are meeting at the point. Reflector light rays are meeting at the point. So those light rays I am considering. Reflector light rays are meeting at the point. So here in this case, you can observe here. So I'm considering in this case. So object is at infinity, image will form at focus. Object is at infinity, image will form at focus. So what is the nature of the image? Real inverted. What is size of the image? Is highly diminished. So here in this case, object is placed beyond center of curvature. Object is placed beyond center of curvature. Image will form between C and F. Image will form between C and F. What is the nature of the image? Real inverted. And size of the image is diminished. Coming to the next one, object is placed at center curvature. Object is placed at center curvature. Image will form at center curvature itself. Object is placed at center curvature. Image also will form at center curvature. So nature of the image is real inverted and same size. If the object is placed between C and F, if object is placed between C and F, so image will form beyond C. Image will form beyond C. So what is the nature of the image? Real inverted and enlarged. So real inverted and enlarged. Compared to the object, only in this case the image is same size. Remaining all the cases before this one, before beyond this point, all are diminished. So more than this point, all images are enlarged. So here we can see object is placed at F, image will form at infinity. Nature of the image is real inverted and size of the image is highly enlarged. So here you can see object is placed between F and P. 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 So one light ray. So here you can see what is the nature of the image. Nature of the image is virtual erect and enlarged image. Virtual erect and enlarged image. So these are the image formations of concave mirror. So these are the image formations of concave mirror. So next one I will go to the convex mirror image formation. Convex mirror image formation. So now I will explain, just check it. When the object is moving towards the mirror, so image will form. So how the image will be, so we need to understand. So next one, convex mirror. Only convex mirror, two cases are there. So convex mirror, only two cases are there. When the object is at infinity, so image will form at focus, and the object is placed between pole and infinity, so image will form between F and P. So I'm considering the convex mirror. So convex mirror, I'm considering convex mirror. So only two cases are there in the convex mirror. So first case is if you are taking the object at infinity, So convex mirror, right? Convex mirror. So I'm taking the convex mirror. So this is a convex mirror. So I'm taking the convex mirror. So here I'm taking. So this is a pole. Focus, so center of curvature, pole, focus, center of curvature. So object is at infinity, image will form at focus. So I'm taking one light ray like this. So another light ray. I'm taking like this. So it reflect back. So if you are extending that one, so those light rays will meet at focus. So here, what is the nature of the image? Virtual, erect and highly diminished. Because object is at infinity, image will form at focus. So virtual, erect and highly diminished. Image will form at focus. So and the next one, second one, if you are considering second one, so I'm taking like this. So I'm considering here. So here object is placed between P and infinity, between pole and infinity. So pole, focus, center of curvature, pole, focus, center of curvature. So one light ray I'm taking like this. So I already said object must be placed anywhere here. Object must be placed here. I'm taking one light ray. I'm taking, so it will be reflected back. Another light ray I'm taking like this. So if you are extending these points, if you are extending this one, here it passes through focus. The image will form between P and F. So here image will form. Okay. So object is placed between P and infinity. So image will form between P and F. Nature of the images. Nature of the images. What is the nature of the image? Virtual, erect and diminished. Compared to the object, image size is decreased. Compared to the object, image size is decreased. Compared to the object, image size is decreased. So that's why I'm considering this the convex mirror. These two are the convex mirrors. These two are the convex mirror. Convex mirror. So do you have any doubts in this? So do you have any doubts? So shall I go to the next one? So mirror image formations. Next one. New Cartesian sign convention. New Cartesian sign convention. All distance measured from the pole. Distance are positive above the principal axis. Distance are negative below the principal axis. So like that I'm considering here. So concave mirror I'm considering this a concave mirror. So like this I'm taking here. Concave mirror, concave mirror, concave mirror, concave mirror. Pole focus, center of curvature, pole focus, center of curvature. So this is the incident ray. This is the incident ray only. This is incident ray direction. So along this incident ray direction, object distance, image distance, focal length, object distance, image distance, focal length, object distance, image distance, focal length and radius of curvature all are positive. So object distance, image distance, focal length and radius of curvature all are negative. So in the direction of object distance, direction of incident rays. So incident rays direction if you are taking, object distance, image distance, focal length and radius of curvature all are positive. Opposite to incident rays of object distance, image distance, focal length and radius of curvature all are negative. So above the principal axis if you are taking, above the principal axis, height of the image and height of the object, height of the image and height of the object both are positive. Below if you are taking, below height of the object and height of the image, so both are negative. So you know coordinate axis, x-axis and y-axis. So positive x-axis, negative x-axis, positive y-axis. So I am taking positive x-axis, negative x-axis, positive y-axis, negative y-axis, negative y-axis. Same thing, same manner we can remember this concept also. Along this direction positive, opposite to this direction negative, above the principal axis positive, below the principal axis negative. So this is about sign conventions. And next one we are going to the next one. So next one you can see. So mirror formula, mirror formula, mirror formula and magnification. Mirror formula is nothing but 1 by f equal to mirror formula. What is the mirror formula? So 1 by f equal to 1 by v plus 1 by u. So 1 by f equal to 1 by f equal to 1 by v plus 1 by u. That is nothing but mirror formula. Magnification, if you are considering magnification, height of the image by height of the object. So magnification is minus v by u. So power of lens is nothing. Power of, this is the power in it will come in lens. So that time I will explain. So this is about mirror. Until here mirror. So we will go to the lens. Lens. So in the next class, I'll explain lens. Lens. So that is about convex lens and concave lens. I'll explain convex lens and concave lens. If I start, so refraction of light I have to explain, refractor index I have to explain. There are many points are there. So then I will explain in the class. So in next class, so I will explain refraction. Refraction at now 3 o'clock, 3 to 4, 5 to 6 I will start. 5 to 6. So 5 to 6, 6 to... Okay, so I will let you know. Anyway, 9 o'clock class is there. So that time I will explain. So we'll go to the next one. Thank you. Thank you from Siva sir.